In the previous unit, we created these subbasin and reach elements, and essentially what happens with the creation of elements is even though we see the subbasin boundaries and the stream as blue line, but Hake HMS doesn't really use any of that. What it needs is the schematic network, and we can see that schematic network by turning off the subbasins and reach elements. So turn off those elements and see how it looks. So to turn off those elements, you'll go to map layers and uncheck reaches and uncheck subbasins. If you want, you can also uncheck the terrain, and that way you will see the actual schematic network here, and that is what HMS uses. So these are our subbasins. Subbasins, they are connected through junctions and reaches, and eventually all the hydrograph from the subbasins are added and routed to get the total flow at the outlet that you see here at the red breakpoint. So this is when HMS's elements are created. Basically, this schematic network is created, and the reaches and subbasins are just for us to see how the drainage boundary and the stream network looks. So now that we know what we have in terms of elements, let's go ahead and add those reaches and subbasins to the map. And for now, I'm just going to leave the terrain unchecked because we really don't need it. And we can basically turn off all the GIS layers. So all we need is subbasins and reaches and the schematic network. Right now we only have subbasins and reaches in our HMS model, but HMS can also incorporate other elements which you don't see here active, but information about this is provided to you in the handout. Now, what we are going to do is we are going to see what methods we have and what parameters we need to simulate the hydrologic process. So I'm just going to check one subbasin here, and after you select that subbasin, you will see the information about it in the component editor here, and it will tell you that the downstream reach is reach 2. We did not provide any description for our subbasin, so which is fine. The lat and longitude information that you see here is basically the location of the subbasin element here on the map, or the centroid of the subbasin. And then we picked some methods earlier when we changed the program settings. So many of these methods are none because we don't need them. The two important methods that we have in all subbasins are the loss method and the transform method. The loss method that we picked was SCS curve number, and the transform method was the SCS unit hydrograph. And then if you want to see the parameters associated with those methods, you will go here and you will see different tabs. So if you click on the loss tab, this is where we are using the SCS curve number method. You will see that the main parameter that we need for the SCS curve number method, which is the curve number, right now we don't have a value here, and also the initial abstraction is blank. So what we are going to do now is we are going to see how to get the curve number for each subbasin. Now eventually HMS will have some functions in the program to get the curve number for all the subbasins using the curve number grid we have. So the version that we are using, which is 4.7.1, does not have that functionality. So what we are going to do instead is we are going to use ArcGIS to extract curve number for all these subbasins, and then we will use the output of that GIS analysis in HMS to get the curve number for all the subbasins. So to do that, let me go ahead and uncheck this subbasin. And now we are going to export the shapefile of all the subbasins so we can use that in ArcGIS. Before we do that, let's also see another way of looking at the parameters, and that can be done by going to parameters and then loss and SCS curve number. And here also, instead of just looking at the parameter for one subbasin, you will see the parameters for all the subbasins, and you can see the curve number is blank. So essentially we are going to populate this column by extracting that information from the ArcGIS analysis. So let's go ahead and export these subbasins into a shapefile so we can use it in ArcGIS. To do that, you go to GIS and then you say export georeference elements. And we want to export subbasins and say next. And we provide the location where we want to save this shapefile, which has an extension of SHP. So we are going to use the same location where I have all the data for this module, which is in C class HMS. So I'll just save it as subbasins.shp and say finish. After we export these subbasins into a shapefile, let's go ahead and open that in ArcGIS Pro. So I will open ArcGIS Pro and let's save this map. I will again save it in the same folder where I have my HMS project. So C class HMS, and we will name the map or project as HMS CN. So we are extracting CN parameter for HMS. You can give whatever name you want. So we don't want to create a new folder, so I will uncheck that and say OK. Now in this empty map, we'll go ahead and add the shapefile that we just exported from HMS. So to add the shapefile, you go to the map tab in the top and say add data. And you can see, since I saved my map in the save folder, I see subbasins.shp. So I'm going to select that and say OK. Now the map did zoom into the location where we have those subbasins, but sometimes it doesn't show up in ArcGIS easily. So a simple fix to that is maybe just change the symbology, and let me pick something else. And even if it doesn't show up after changing the symbology, another way to make sure that the shapefile is added is just open the attribute table and select all the features, and you will see that the subbasin exists in ArcMap, but for some reason it does not show up sometimes, and that has to do with some interoperability issues with the shapefile format that HMS created. So we don't really need to worry as long as we know that the shapefile exists. It's just some issue with the map display. So now that we have these subbasins in ArcMap, let's go ahead and add the curve number grid. So again, we will use the add data button and say cngrid.tif. And now our CN grid is added. So what we are going to do next is we are going to use zonal statistics, and we will get the mean value of the CN grid for each of the subbasins. So to use zonal statistics, we will go to geoprocessing, we will go to toolboxes, then we will go to spatial analyst tools, and within spatial analyst we have zonal. and then we will use the zonal statistics as table. Our input features are going to be subbasins. The zone field is a field that we want to use to identify our subbasins. We will use name. So if I open the attribute table, so the name field has all the names, subbasin 1, subbasin 2, so we will use that to identify. Now I have selected all the subbasins, so either you can select all of them or not select any of them, okay? So it should still work, but if you just select one or two, then it will calculate the zonal statistics only for those selected polygons. So either select all of them or don't select any. And the input value raster, so this is our curve number grid, and we will name the output table as, let's, in the same folder C class HMS, I'm going to name this table as cn value dot dbf. Now dbf is a table format that is supported by ArcGIS, so cn value dot dbf, and then we have statistics type. So we don't want all the statistics, we just want the mean value. So to keep our output table simple, I will pick the mean value and say run. And after the table is created, it will be added to the map document. So if you open the attribute table, now you will see the subbasin name here in the name field, and you will see the mean value. So the mean value is the curve number that we have for each subbasin. So what we have to do now is basically get this mean value column into the HMS CN parameter column that we earlier saw was empty in HMS. Now to get these values, what I'm going to do is I'm going to open this dbf file in Excel, then just copy this column and paste it in HMS. So I'm going to save my map, minimize it, and open Excel. So blank workbook is fine. And then I will go to File, Open, in the same folder where I saved the dbf file. So C class HMS, and then you will see the cn value.dbf. Now you will see two dbf files. One is an XML file and the other one is the dbf file. So you want to add the dbf file, not the XML document. So I add the dbf file, open, and here we have all the subbasins and the mean value. So let me just go ahead and sort these by name, and then we will use the same sorting in HMS and just copy paste. So to sort the values by name field, I can go to data in Excel and sort by name. So once I do that, you will see it is sorted with the name. So subbasin 1, 11, 12. After 18 we have 2, 3, 4 until 9. Now this sorting is good in Excel, so let's go ahead and do the same in HMS. So I will go back to my HMS tab here and open the parameter table. So to do that, I will go to parameters here, loss, and SCS curve number. And let's also sort these by subbasin name, and you can do the sorting by using this option here on the top right corner. So right now the sorting is by hydrologic elements, so let's do alphabetic. And with alphabetic, again, you can see it is similar to what we have in Excel. So 1 until 18, and then 2, it goes until 9. So what I'm going to do is I'm going to copy these values. So select, right click and copy, and then go to HMS and then paste it in the curve number column. And you can see all the values are pasted now. So apply, and you will now see that for each subbasin, if you go to loss, you will see the curve number. Okay, so we now learn how to extract curve number values for each subbasin. As I mentioned, we currently don't have a tool to do this easily in HMS. In future we may, but even now it is not that difficult because we use the same functionalities that we have used earlier in ArcGIS, which is the zonal statistics tool, and we now have the curve number values for the loss method. In the next unit, we will see how to get the lag time for the transform method. So this is it for this unit. Save your project.